This video is for class 9 physics, and today we are doing numericals on pressure in fluids from exercise 4a. This is from exercise 4a. Okay, here are few formulas, okay, which you need to know, and they are P equals to H rho G, which is pressure exerted by the fluid, will be equal to height of the liquid column or the fluid column. Rho stands for density of the liquid, whereas G stands for acceleration due to gravity. The another formula is P equals to F upon A, that is pressure equals to thrust upon area. And the last one here is the principle of hydraulic machines, which is F2 upon F1 equals to A2 upon A1, where F2 represents the force generated on the area of a bigger piston, whereas F1 is the force applied on the area of a smaller piston, where A2 is the larger area and A1 is the smaller area, right? So here what we are using is F2 is the larger force, bigger than F1, and A2 is the larger area, bigger than A1, right, as we have studied in our theory. So let us go to the first question from the exercise 4a. The first question reads as: a hammer exerts a force of 1.5 Newton. So your thrust is given to us, which is 1.5 Newton on each of the two nails. So two nails are given, A and B. The area of cross section of the tip of nail A is 2 mm square, while that of nail B is 6 mm square. Calculate the pressure on each nail in Pascal. So this is quite easy here. We are supposed to find the pressure, right? Force is given to us, right? And area is also given to us. Hence, we can use this formula P equals to F upon A and then find the answer. Okay, let us go to its solution. So coming to the solution of number 1, given F equals to 1.5 Newton. For nail A, we know that area is 2 mm square, right? 2 mm square. I need to convert this 2 mm square into meter square. As you all know, we can convert it by dividing by 1 followed by 6 zeros, okay? 1 followed by 6 zeros, right, which is 10 lakh. So how do we get 10 lakh is like first 10 into 10 is to convert it into centimeter square, and then 100 into 100 is to convert it into meter square. So that's why I've separated them just to make you understand, right? Now we can use the formula, which is P equals to F upon A. F given to us is 1.5 Newton, whereas area is 2 upon 10 lakh meter square. So when we do the calculation, right, we're getting 1.5 upon 2. When I remove the 0.110 comes here, and this denominator, I need to reciprocal it, hence I am getting this numbers here. So after cancellation and all, okay, we shall get 7.5 into 10 to the power 5. 7.5, here we're getting 7.5 into 10 to the power 5, because there are 5 zeros left, pascals, because Newton per meter square is Pascal. Now for nail B, area given to us is 6 mm square. Again, I can convert it into meter square by dividing by 10 lakh here. Now using the formula for pressure, which is P equals to F upon A, and then replacing the values, we shall get P equals to 1.5 Newton upon 6 upon 10 lakh meter square. Again doing the calculations, right, and the cancellations, etc., we are getting 2.5 into 10 to the power 5 Pascal. So this is the second answer. Okay, I hope you have understood number 1. Now I think we can go to number 2. Now coming to question number 2, it reads as: a block of iron of mass 7.5 kg and dimensions 12 centimeter multiplied by 8 centimeter multiplied by 10 centimeter is kept on a tabletop on its base side, which is 12 centimeter into 8 centimeter. So this 12 centimeter into 8 centimeter is supposed to be its area, right? Calculate number A, thrust, number B, pressure exerted on the tabletop. Take 1 kgf equals to 10 Newton. Take 1 kgf equals to 10 Newton. Okay, let us go to its solution. Coming to the solution of number 2, where a mass given to us was 7.5 kg and we were supposed to find the thrust. Now, as you all know, thrust is equal to the weight of the object, right? And so from the mass, I'm supposed to find the the weight first and then the thrust. If I find the weight, then that will be equal to the thrust. So weight of the iron block will be 7.5 kgf, right? Because if I add f here, so it will change into weight. If I just need to add f out there. So now this is my weight, but thrust should be in Newton because I need to calculate the pressure afterwards also, right? Therefore the thrust will be 7.5 kgf. If I want to convert it into Newton, this relationship is given in the question, which is 1 kgf equals to 10 Newton. Thus thrust will be equal to 7.5 into 10, which is 75 Newton. This is the thrust given by that iron block. Now number B, I'm supposed to find the pressure. So area is 12 centimeter into 8 centimeter, right? This was the area. So I need to convert it into meter. So that is 12 upon 100 meter multiplied by 8 upon 100 meter. Hence I am getting 12 into 8 upon 10,000 meter square. So this is our area. Now from this area we are supposed to find the pressure. Now using the formula for pressure, which is P equals to F upon A, right, and then replacing the values of F and A, where F was 75 Newton, whereas A is 12 into 8 upon 10,000 meter square. Now P equals to 75 Newton multiplied by 10,000. As you all know, this will go to the numerator, right? Now then we can do the calculation, hence get the answer as 7812.5 Newton per meter square. So I hope you can do the calculation part. Okay, I don't want to waste much time in calculation. Okay, so I think you can do the calculation, right? Simple division, simple multiplication, etc. Right? Now we can go to question number 3. Going to question number 3, a vessel contains water up to a height of 1.5 meter. So height is given to us 1.5 meter. Therefore and water is mentioned here. A vessel contains water. Therefore I am supposed to use the formula P equals to H rho G, right? Because this formula is used for fluid pressure and height is given to us. Now taking the density of water as 10 to the power 3 kilogram per meter cube, acceleration due to gravity as 9.8 meter per second square, and the area of the base of the vessel is 100 centimeter square. Calculate the pressure and the thrust at the base of the vessel. Okay, so in the number A, I'm supposed to calculate the pressure and then the thrust. Okay, it is just reverse of the previous sum. So let us try to solve this. Okay, so coming to solution number 3, given height is 1.5 meter, density is 10 to the power 3 kilogram per meter cube, and acceleration due to gravity given to us is 9.8 meter per second square, and the area which is given to us was 100 centimeter square. I need to convert it into meter square, so I need to divide 100 by 100 into 100, right? But initially I am supposed to find the pressure and then the thrust. Okay, so using the formula P equals to H rho G here, and then replacing the values of H, rho and G, and then by simply multiplying it. Okay, simple multiplication, I am getting 14700, which is 14,700 kilogram meter per second square by meter square, which is Pascal. Okay, how do we get this? All units are Pascal. Okay, let's see. Here, sorry, here we are getting kilogram meter per second square upon meter square, because this meter can, sorry, because this meter can cancel one of the meter here, because 3 m into m, there are 3, so it becomes m square, right? Now kilogram per meter square, kilogram into meter square, which is force into acceleration, which is mass into acceleration, should be Newton, right? Whereas meter square comes here, so Newton per meter square is Pascal, hence we're getting unit as Pascal. You don't have to show all this calculation here, it's optional, right? It's up to you. Okay, directly you can write Pascals here, because all the calculations we are doing in the SI unit. Okay, now we can go to the next part, that is part B. I'm supposed to find the thrust. Now using the formula, thrust, okay, is equal to pressure into area. It should be equal to pressure into area. Now just now we have calculated pressure, that is 14,700 Pascal, multiplied by area, which is 100 upon 100 into 100. So after cancellation, right, and then multiplication, we are getting 147 Newton. I hope you understood number 3. Let us go to number 4. Number 4 is same as number 3, so I guess you can try it by yourself. Okay, so please do it by yourself, right? Please do it by yourself. Please do all the sums in your exercise book. So this much for this video. In the part 2 of this video, I shall bring the solutions of number 5, 6, 7, etc. Okay, thank you so much.